Hello, my friend. Tonight, let us drift somewhere both impossibly far away and closer than your own breath. You are sitting inside a galaxy right now, 100 billion stars or more, turning slowly through the dark, and you are folded into the middle of it, riding one quiet arm of it as it wheels. And here's the strange thing, the thing that will carry us gently through tonight. This place we belong to, the Milky Way, our own home, is one of the least understood things we have ever tried to study. We can photograph galaxies far across the universe in crisp and confident detail. Our own, the one cradling us this very moment, we have never even seen from the outside. So let yourself settle now. Let your shoulders grow heavy and your breathing slow. There is nothing here you need to follow, nothing to remember, nothing to hold. Tonight I'm going to tell you about 20 things we still do not understand about our own galaxy. Real mysteries, the kind that working scientists puzzle over beneath the same sky you are resting under. Some are wonders we have only just noticed. Some are questions older than anyone alive. You do not have to carry a single one of them. Just let them drift past you, one by one, like distant lights through the window of a slow night train, while you sink softly down towards sleep. No one has ever seen the galaxy you are living in. Picture, for a moment, every image of the Milky Way you have ever come across. That glowing pinwheel of light, the great spiral arms curling out from a bright golden center, the whole vast wheel hanging in the black like a slow firework frozen in place. It is beautiful. It is familiar. And not one of those pictures is a true photograph of our galaxy. Every single one is either a painting, a computer's careful guess, or a photograph of some other galaxy far across the universe, borrowed to stand in for our own. The reason is simple and a little dizzying when you rest with it. To take that picture, you would have to journey far above the galaxy and look back down upon it. And the galaxy is so enormous that no craft we have ever built could make that voyage in 1,000 million lifetimes. We are inside it. We have always been inside it. You are sitting right now, about 26,000 light years out from the center, settled into the flat plate of the disk, gazing out at the rest of it from within. That is why, on a truly dark night, far from the glow of any city, you can see the galaxy with your own eyes as a pale band of light stretched across the sky. That soft, misty river the old stargazers named the Milky Way. You are looking edge-on, straight through the disk you are embedded in, and that glow is the blended light of countless stars, far too distant and too faint for your eye to pull them apart. You are seeing your home the only way anyone ever has, from the inside, looking out. So how do we map something we can never step back from? We do it rather like someone trying to draw the floor plan of a vast darkened house while standing in a single room, never allowed to leave, feeling for the walls and listening to echoes. Astronomers measure the distances and the motions of stars and great clouds of gas, one patient point at a time, and try to fit them together into a shape. And it is hard. It is so much harder than mapping a galaxy we can see whole from the outside, the way we can with so many others. Here is just how hard. For a long time, the textbooks drew our galaxy with 4 grand spiral arms, sweeping curves of stars and gas winding out from the core. Then, not so many years ago, surveys peering through the dust and infrared light suggested something different. Perhaps there are really only 2 major arms, with the others being smaller, fainter spurs branching off in between. Even now, astronomers do not entirely agree on how many arms our galaxy truly has, or exactly where each one lies. We are still gently arguing over the basic shape of the thing we live inside. And it is not only distance that hides our galaxy from us. It is dust. Drifting between the stars are vast clouds of fine dark grains, the soot of ancient suns, and they soak up visible light the way fog soaks up the glow of a street lamp. When you turn your gaze toward the center of the galaxy, toward the brightest and most crowded heart of it, you are looking straight into the thickest of that fog. Almost none of that light ever reaches your eye. For most of human history, the very middle of our own galaxy was completely invisible to us. Veiled behind curtains of dust, we had no way to part. Only by looking in other kinds of light, in infrared and radio waves that slip through the haze, have we begun to glimpse what waits behind it, and all of it is quietly moving. You feel perfectly still, lying there in the dark, and yet you are being carried around the center of the galaxy at a speed almost too large to hold in the mind, something close to 500,000 miles in every hour. Even at that pace, the galaxy is so immense that to complete a single loop around its center takes more than 200 million years. The last time this very patch of space you are resting in came around to where it is now, there were dinosaurs walking the Earth. One turn of the galaxy is longer than the whole age of flowers, and we have only ever watched the smallest sliver of a single turn. There is a strange and gentle kind of blindness in all of this. We can photograph a spiral galaxy 30 million light years away and trace its arms with a clarity we simply cannot achieve for our own. The one place in all the universe we belong to most completely is the one place we can never quite stand back and behold. We seem to know the far shore better than we know the ground beneath our feet. And yet the truest picture of the Milky Way is not some grand image waiting to be captured by a future probe. It is the one you may have already seen with your own eyes on a clear night under a quiet sky, that soft band of light arching overhead. It is not a diagram or a rendering. It is the inside of your own galaxy, glowing faintly above you, the only portrait of home we have ever been given. So tonight you do not need to picture it from far away. You are already in the picture. Folded into one of its glowing arms, turning slowly with all the rest, held inside the soft and unseen shape of the Milky Way. Most of your galaxy is something no one can see. For thousands of years, we assumed a galaxy was simply its stars. The lights are the thing we thought, and the darkness between them is only empty space, a backdrop, a nothing. Then, a few decades ago, an astronomer named Vera Rubin set out to measure something that seemed almost routine. She wanted to know how fast stars orbit at different distances from the centers of galaxies. She knew what she expected to find, because we see the very same pattern close to home. In our own solar system, the inner planets race around the sun quickly, while the outer planets drift around slowly, because the sun's gravity grows weaker the farther out you go. The same ought to be true of a galaxy. The stars near the bright crowded center should whirl around fast, and the stars way out at the lonely edges should trail along far more gently. That is not what she found. Out at the edges, where the stars grow sparse and the visible matter thins almost to nothing, the stars were not slowing down at all. They were sweeping around just as fast as the stars much closer in. It was as though some enormous, unseen weight were out there as well, wrapped all around the galaxy, pulling on those distant stars and hurrying them along. Imagine a carousel turning in the dark. The horses near the middle and the horses out at the rim all swing around together. But the ones at the rim are traveling a far longer path, far faster. And if the ride were truly only those painted horses, the outer ones should fly off into the night. For them to stay, something unseen must be holding them. Some great hidden mass woven all through the machine. So there must be something out there, a vast amount of it, something that has weight and pulls with gravity, and yet gives off no light of any kind, neither the light we can see, nor the light we cannot. We have given it a name. We call it dark matter. And the honest truth is that the name is mostly a confession of how little we know. We cannot see it. We do not know what it is made of. We only know it by the way it pulls, and there is so much of it. When you add up all the dark matter a galaxy seems to hold, it outweighs every star, every cloud of gas, every planet and grain of dust combined, by something like 5 or 6 times over. The galaxy you picture as a glittering disk of stars is really a faint sprinkle of light suspended inside a far larger, invisible cloud. A great dark halo, round and deep, reaching out well beyond the edge of everything that shines. Without it, the galaxy could not even hold itself together. Spinning as fast as it does, it would have flung its stars away into the dark long ago. Something we cannot see is the very thing keeping the whole wheel whole. We have searched for it for a very long time. We have built exquisitely sensitive detectors and buried them deep underground, beneath mountains of solid rock, waiting in the dark for a single particle of this hidden stuff to brush against ordinary matter and leave the faintest trace. So far, mostly silence. The dark matter slips through everything, through the rock, through the detectors, through you and me as you lie here, leaving almost no mark at all. There is even a quieter, more radical possibility that some scientists keep returning to. What if there is no hidden substance at all? What if, instead, our understanding of gravity itself is slightly wrong on the vast scale of galaxies? And that is what makes those outer stars move the way they do. This idea, sometimes called modified gravity, remains very much a minority view among astronomers, and most of the evidence still points toward real unseen matter. But it lingers, a small, honest reminder of just how open this question still is. Sit with what it means for a moment. Almost everything is hidden. The stars you can see, the galaxies, all the glowing structure of the night, may be little more than a thin froth of light floating on the surface of a dark and silent ocean whose depths we have barely begun to touch. The cosmos we admire is mostly the part we cannot perceive. So the next time you look up at a scattering of stars, know that you are seeing only the smallest part of what is truly there. Around every one of them, and around you and through you, drifts a vast and silent presence. It asks for nothing. It shows nothing. It simply holds the whole slow wheel of the galaxy gently together and turns with you, all through the night. There are 2 enormous bubbles rising out of the center of your galaxy, and no one even knew they were there until the year 2010. They are almost beyond imagining in size. Each one swells out from the core of the galaxy, one reaching up above the flat plane of the disk, and one reaching down below it, like a pair of vast glowing balloons breathed out from the center. Each bubble stands roughly 25,000 light-years tall. Put the 2 together, top to bottom, and they stretch across a span you could compare to half the width of the entire galaxy. They are among the largest structures attached to the Milky Way. And for the whole of human history, through every age of stargazing, no one had the faintest idea they existed. The reason we miss them is itself a wonder. These bubbles shine, but they shine in a kind of light our eyes can never catch. They glow in gamma rays, the most energetic light there is, far beyond the colors of any rainbow, far beyond even the invisible warmth of infrared. To see them, you cannot use an ordinary telescope, and you certainly cannot use your eyes. You need a special telescope flown high above the air, watching the sky in that fierce, hidden, high-energy glow. And so it was a gamma-ray telescope, drifting in orbit and patiently mapping the whole sky, that finally revealed them. When astronomers carefully cleaned away the nearer foreground glow and looked at what remained, there they were. Two titanic lobes, strikingly smooth and symmetric, ballooning out from the heart of the galaxy, above and below, quietly enormous and utterly unknown until that moment. What are they actually made of? They are not walls or shells you could ever touch, but vast regions of thin, scorching gas and fast-moving particles, hot enough and energetic enough to pour out that fierce gamma-ray light. They are more like two enormous puffs of glowing breath than anything solid at all. And as if to deepen the mystery, when astronomers later studied that same part of the sky in yet another invisible light in X-rays, they found something even grander still. A second, even larger pair of bubbles, wrapping around the first like a faint outer shell, reaching farther out into the dark. Bubbles nested within bubbles, towering silently over the galaxy from its very center. We are still, even now, only beginning to understand how they came to be, or how the two great pairs are related. Then came the real question, the one we still cannot fully answer. What blew them? To inflate bubbles on this scale, something must have poured a staggering amount of energy into the center of the galaxy, enough to push glowing material tens of thousands of light years out into the dark. There are two leading ideas, and both of them are dramatic. The first points to the supermassive black hole that sits at the very center of the galaxy. Today it is mostly calm and quiet, but black holes are not always so gentle. In the past, it may have fed on a great rush of gas, and as that gas spiraled in and was torn apart and heated, the black hole could have blasted out twin jets and searing winds of material, breathing these two vast bubbles into being like air pushed into a balloon. The second idea is gentler in its source, though just as mighty in its effect. Perhaps long ago, the central region of the galaxy gave birth to a great burst of new stars, many massive suns lighting up close together. Massive stars live fast and die young, and when they die, they explode. Countless such explosions, near to one another in time and place, could have driven an enormous outflow of hot gas, pushing it up and out into the two lobes we see today. Both of these are theories. We do not yet know for certain which one is right, or whether the truth is some mixture of the two, or how very long ago the great event took place. The bubbles themselves are real and clearly there. Their origin is still a genuine open question, a riddle written in a light we cannot see. There is something humbling in all of it. Some of the very largest features of our own galaxy were entirely unknown to us until just a handful of years ago. The sky we believed we knew so thoroughly was still keeping something this immense, waiting patiently in a color we had simply never learned to see. And they are out there right now, those two great quiet bubbles, glowing softly in a light no eye can hold, arching high above and far below the galaxy like a pair of enormous still wings. They carry within them the memory of some long ago fire at the center of everything, a fire that no one was here to witness, breathing out into the dark, slow and silent, far above the soft band of stars. At the very center of your galaxy, something is making antimatter. Antimatter is one of the strangest things in all of physics, and yet it is entirely real. The rule is this: for every kind of ordinary particle, there exists a mirror twin, identical in almost every way, but carrying the opposite electric charge. The mirror of the tiny electron even has its own name. It is called the positron. And here's the part that feels like something out of a story. When a particle of matter meets its antimatter twin, the two do not simply collide. They annihilate. Both of them vanish completely, utterly, and in the place where they were, there is nothing left but a flash of pure energy, a burst of light. In this case, a gamma ray of one very precise color. So when astronomers turn their instruments toward the center of the galaxy, they see exactly that. A steady, glowing signal of gamma rays at the precise energy produced when an electron meets a positron and the two wink out together. It is an unmistakable signature, like a single note struck again and again. Somewhere near the heart of the galaxy, vast numbers of antimatter positrons are being created, meeting ordinary electrons and vanishing in tiny silent flashes of light. We can only see this glow from above the Earth because gamma rays do not pass easily through our atmosphere, which is a mercy for all life and an obstacle for astronomers. So it took telescopes flown high above the air to notice the steady signal and recognize it for what it was. A constant, patient beacon at the center of the galaxy, quietly broadcasting the news that antimatter is being born and destroyed there without pause. And the amount is almost impossible to picture. Every second, near the center of the galaxy, a quantity of antimatter is being made and unmade that would dwarf anything we could ever produce on Earth in all of our history. A constant, gentle rain of matter meeting its mirror, flaring once and letting go. To keep that glow shining as steadily as it does, the source must be enormous and never resting. There is a strange tenderness in the picture if you let yourself see it. Out of all the violence at the center of the galaxy comes this steady, almost rhythmic shimmer. Particle and mirror particle finding each other in the dark and quietly disappearing over and over in a glow that never flickers out. It is one of the most reliable signals in all the sky, a soft and patient pulse from the very heart of our home. We have been watching it carefully for decades now, and the longer we look into it, the more questions it seems to hold, and the further we seem to drift from any simple answer. This is where it becomes a true puzzle. We do know that antimatter can be made by certain natural processes, so the glow is not magic. The radioactive ashes left behind by exploding stars can release positrons as they slowly decay. Spinning collapsed stars can fling antimatter out into space, and so can pairs of stars locked together where one is feeding hungrily upon the other. There are real, known sources, and they surely account for some of it. And yet, when astronomers carefully add up every source they can think of, they struggle. They struggle to account for the full amount of antimatter. And even more, they struggle to explain the shape of it, the way the glow is spread across the center of the galaxy. It is oddly lopsided. It is not arranged in the neat, balanced way we would expect if it came only from the ordinary sources we understand. It is tilted and uneven in a manner that has quietly puzzled astronomers for years. Because of that, some researchers have wondered whether something more exotic might be involved. There have been suggestions, for instance, that the mysterious dark matter, the unseen stuff that fills the galaxy, might somehow be producing antimatter at the center. That idea is far from proven, and it remains only one possibility among several. For now, the honest answer is simply this: we are not entirely certain what is making all of that antimatter at the heart of our galaxy. There's a quiet strangeness in sitting with that. Antimatter is the most science fiction substance imaginable, the very stuff of impossible engines and faraway stories, the kind of thing you might expect to exist only in the pages of a novel. And here it is, being made in great and ceaseless quantities in the middle of the very galaxy we call home, by some hand we have not yet managed to name. It is happening right now, far beyond the dust and the crowded inner stars, a soft, invisible glow at the center of everything. Matter and its mirror meeting in the dark, flaring once in a light no eye can see, and gently, endlessly letting go. At the center of your galaxy sleeps a giant. It is a black hole, and not an ordinary one. It holds about 4 million times the mass of our sun, all of it crammed into a space smaller than the orbit of the innermost planet. We call it Sagittarius A star, after the part of the sky in which it lies. It sits at the exact heart of the galaxy, and everything, our own sun included, slowly circles around it across the long ages. You cannot see the black hole itself. By its very nature, nothing escapes it, not even light. So it gives back nothing at all to our eyes, only a perfect, silent darkness. And yet we know it is there, and we know its weight with remarkable precision, because we can watch the stars closest to it. Right near the center, a small group of stars swings around something unseen on tight, swift, looping paths, like moths circling an invisible flame. From the shape and the speed of those orbits, we can weigh the darkness they are circling, and the answer always comes back the same. 4 million suns hidden inside a single point. In recent years, we managed something that once seemed impossible. By linking telescopes all across the Earth into a single great eye, astronomers captured an actual image of the region right around it. Not the black hole itself, which gives off no light, but the glowing ring of hot matter circling its very edge, with the round shadow of the darkness resting at the center. A real picture of the silhouette of the thing at the heart of our galaxy. And even with that picture in hand, what it is doing remains a puzzle. Here's the strange part. In a great many other galaxies, the central black hole is a creature of terrible activity. As gas spirals down toward it, the gas is crushed and heated until it blazes, shining brighter than all the hundreds of billions of stars in its galaxy put together. A beacon so brilliant it can be seen clear across the universe. Our own black hole does almost none of this. By the standards of its own kind, Sagittarius A star is astonishingly quiet. It sips only the faintest trickle of material. It glows only dimly, and it behaves far more like something resting in a deep and patient slumber than like a raging engine at the center of the world. Even in the depths of its slumber, it is not perfectly still. Now and then, astronomers watching it closely catch a brief flicker. A sudden small brightening that flares up over the course of a few hours and then quietly fades away again. Like a sleeper shifting beneath the blankets, or murmuring softly without ever truly waking. No one fully understands these little flares either, what feeds them, or why they come and go the way they do. They are simply part of the quiet, restless dreaming of the giant at the center of the galaxy, small stirrings within a very long and very deep sleep. And yet there are hints that it has not always slept so peacefully. Far out beyond the center drift great clouds of gas, and some of them shine with a faint light that looks, to astronomers, very much like an echo. Like the reflection of a flash that left the center long ago and is only now arriving at those distant clouds, lighting them up as it sweeps past, the way a thunderclap reaches you well after the lightning. By reading that echo, some astronomers have come to believe that just a few hundred years ago, perhaps around the time the first telescopes were being raised toward the sky on Earth, our sleeping black hole briefly woke. It flared far brighter than it shines today, blazed for a while, and then settled once more into quiet. So we are left with gentle, genuine questions. Why is it so calm now, when so many of its kind devour gas so fiercely and shine so fiercely? What stirred it those few centuries ago, and then let it fall still again? We do not fully know. The very heart of our galaxy seems to wake and sleep on some slow rhythm we have not yet learned how to read. There is something almost tender in imagining it that way. A vast and patient darkness at the center of everything, mostly dreaming through the eons, stirring now and then across the great stretch of time, then settling back down into stillness. Tonight it does not seem like a monster at all. Tonight it seems more like something simply asleep. And it is there right now, that sleeping giant, some 26,000 light years away from where you are resting, holding the entire galaxy in one enormous, unhurried circle around itself, calm and dark and still, while you and every star you have ever seen drift slowly around it through the long and quiet night. Right beside the black hole at the center of the galaxy, there are young stars that should not be able to exist. To understand why that is so strange, it helps to remember how a star is born. It begins as a cloud of gas, cold and dark and drifting. Slowly, gravity draws the gas inward, gathering it, pulling it tighter and denser, until the very core grows so hot and so crushed that it ignites and begins to shine. It is a slow and delicate process, and above all, it needs a certain peace. It needs a quiet region where the gas can gently collect, undisturbed, with time enough to fall together. Now think of where the central black hole lives. The space immediately around it is the very opposite of peaceful. So close to 4 million suns worth of gravity, the pulling forces are savage, and they do not pull on an object evenly. They pull far harder on the near side than the far side, stretching anything that wanders close, dragging it out long and thin. A drifting cloud of gas that strayed in too near would be stretched and sheared and torn into ribbons long before it could ever gather itself into a star. By every reasonable expectation, the region right around the black hole should be barren, swept clean, the last place in the entire galaxy where anything new could be born. And yet, when astronomers looked closely at that exact region, peering through the dust with their most careful instruments, they found stars. Not old, faded, gentle stars, but bright, hot, massive young ones. The kind of star that burns through its life fiercely and quickly, which means it cannot possibly be ancient. It must have formed recently, almost in cosmic yesterday. Stars that, by everything we believe we understand, should never have been able to take shape where they are sitting. The puzzle was so striking that astronomers gave it a name that fits it perfectly. They call it the paradox of youth. And it is not only the stretching forces that make the place so hostile. The center of the galaxy is fierce in nearly every way you could name. It is flooded with radiation, crowded with countless stars sweeping close past one another, washed in the heat and the wind of everything churning around the black hole. It is, by almost any measure, one of the most extreme environments in the entire galaxy. A place where the gentle, patient work of building a new star out of a quiet, drifting cloud should be all but impossible. And still, somehow, against all of it, there they are, shining. Some of these stars orbit so close to the black hole and move so astonishingly fast that they sweep all the way around it in only a decade or two. Our own sun needs more than 200 million years to circle the distant center a single time. These stars race a full loop around the darkness itself within a single human lifetime, again and again. To find stars so young, moving so impossibly fast, in a place that should have torn them apart before they were ever born, only deepens the wonder of how they came to be. So, how did they come to be there? Several ideas have been offered, and it is important to say plainly that none of them has been confirmed. Each is a careful attempt to explain something we genuinely do not yet understand. One idea suggests that the gas, instead of being torn apart, was somehow gathered into a great disk wrapped tightly around the black hole, and that within the crowded heart of that disk, the gas grew dense enough to collapse into stars after all, sheltered by its own weight against the shearing forces. Another idea suggests that the young stars did not form near the black hole at all. Perhaps they were born far away, out in a calmer part of the galaxy, and were then flung or drawn inward over time, migrating toward the center, arriving young in a place where nothing young should be. Each of these ideas has its strengths, and each has its troubles. The truthful position for now is that we are still not certain how those bright young stars came to shine so close to the heart of the galaxy. And there is something quietly moving in that uncertainty. In the most hostile, most violent corner of the entire galaxy, right at the trembling edge of the great darkness, where everything we know says creation should be impossible, new light found a way to begin anyway. Stars were kindled in the one place stars seemed forbidden. They are circling there even now, those impossible young stars, swinging in tight and brilliant arcs around the darkness at the center, burning calmly and steadily in a place that ought, by every rule, to be empty, shining on quietly against all expectation in the deep and ancient heart of the galaxy you call home. Circling the black hole at the center of the galaxy are a few quiet objects that no one has been able to fully explain. They were noticed by astronomers who had spent years patiently watching the very center of the galaxy, carefully tracking the many things that orbit the great black hole there. Among the ordinary stars wheeling around in their orbits, the astronomers caught sight of something that did not fit. A small number of objects that simply did not behave like anything familiar. When they are far from the black hole, spread out and faint, these objects look for all the world like simple clouds of gas, soft, diffuse, hazy things, the sort of gentle smudge you might expect to slowly thin out and drift away. But then each one swings inward on its long orbit, in toward the black hole, into the region of the very fiercest gravity, where the pulling forces are so violent that an ordinary cloud of gas would be stretched into thin ribbons, torn apart, and swallowed. And these objects do not come apart. They sail straight through that gauntlet of crushing forces, hold themselves together, draw back into a compact shape, and continue calmly along their orbit, as whole and intact as if they were solid. As though, hidden somewhere inside that soft gassy haze, there were something dense and durable and stubborn at the core. Something heavy enough to keep the whole thing from being ripped away. Something, in other words, much more like a star. So here's the contradiction that makes them a mystery. From the outside, they look like clouds of gas, but they behave like stars. They wear the appearance of one thing and carry the strength of another, and we cannot yet fully reconcile the two. Astronomers gave them a plain and modest name. They simply call them the G objects. The first of them drew real attention some years ago, when astronomers watched one of these objects swing in toward its closest approach to the black hole. Many expected a dramatic show. They thought that as it passed through the region of fiercest gravity, it would be shredded and partly devoured, flaring brightly as the black hole fed upon it. They waited and they watched, and the show never came. The object rounded the black hole and sailed back out, battered perhaps, but whole. It was that quiet survival where fireworks had been expected that first revealed these things were not the simple clouds they appeared to be. Since then, astronomers have found only a small handful of these strange objects in all the vast, crowded center of the galaxy, and they have followed them patiently, year after year, watching each one trace its slow orbit around the darkness. A few quiet puzzles drifting among the great multitude of stars, rare enough to feel precious, and strange enough to keep us gently wondering what they are, long after we first noticed them. There is a leading idea about what they might truly be, and it is a strangely beautiful one, though it is not yet settled. The most popular suggestion is that each of these G objects may be the result of two stars that slowly spiraled together, closer and closer over a very long time, until at last they merged into a single new star. Such a merging would be a violent and untidy event, and it could leave behind one star wrapped in a great puffed-up envelope of gas, the leftover bloat of that union, still slowly settling. That would neatly explain the puzzle. The soft gassy cloud we see on the outside, and the dense, durable star hidden at the center, holding it all together. It is a compelling picture, but it has not been proven, and other explanations are still on the table. We are genuinely still working out what these strange objects truly are. And there's a quiet lesson tucked inside that uncertainty. The center of our galaxy is perhaps the single most closely studied patch of sky in all of astronomy. We have pointed our finest instruments at it for many years, watched it more carefully than almost anywhere else in the heavens. And even there, even under our most patient and devoted gaze, there are things we have found but do not yet understand. The heart of our galaxy still keeps a few of its secrets gently to itself. So they go on, those few soft riddles, looping slowly around the great darkness at the center of everything. Clouds that will not scatter, stars dressed as mist, drifting along on their long and patient orbits through the dark. Things we can watch night after night, but cannot yet fully explain. And perhaps for tonight, they do not need explaining. Perhaps it is enough to know they are there, turning quietly in the deep heart of the galaxy as you grow quiet here. The galaxy you live in is not flat. We love to picture the Milky Way as a perfect disk, a great smooth plate of stars turning evenly through space, like a record spinning on a turntable or a vast pancake of light. And across most of its width, that picture is a fair one. But out toward the edges, the disk does something quietly unexpected. It bends. One side of the outer rim curls gently upward, lifting out of the flat plane, and the opposite side curls gently downward, sinking below it, so that the whole outer edge of the galaxy is warped. It is shaped a little like the brim of a soft hat, pinched up on one side and pressed down on the other. Or like a vinyl record left too long in the sun, its flat face gone soft and wavy at the rim. The Milky Way is not a tidy plate at all. It is a warped one. And this warp is enormous. The bending takes place far out in the outer disk, many thousands of light years from the center, where the stars grow thin and scattered. If you could somehow rise high above the galaxy and look at it edge on, you would see it plainly. The graceful curve of the disk, lifting up at one far edge, dipping down at the other, a single slow ripple frozen across 100,000 light years of stars. For a long time, astronomers could only trace the warp faintly in the cold hydrogen gas that fills the outer galaxy. Only more recently, by carefully mapping the positions of vast numbers of stars, have we been able to see the true shape of the bend and to follow it with real precision. Just how far does the edge of the disk lift and fall? Out at the rim, the warp carries stars thousands of light years above and below where a flat disk would place them. Spread across the immense width of the galaxy, that is a gentle slope, almost imperceptible if you were standing among those outer stars. And yet, seen as a whole, from far enough away, it is unmistakable. A slow and graceful curve running through the entire outer galaxy, the kind of shape you might trace in the air with a single sweep of your hand. And here is the part that took astronomers by surprise. The warp does not sit still. It moves. The whole great bend slowly turns around the galaxy over time, the crest of the lift traveling around the center like the wobble of a spinning top that has just begun to lean, or the slow circling tilt of a coin spun on a tabletop in the last moments before it settles. By tracking how huge numbers of stars are positioned and how they drift, astronomers have actually managed to measure this motion. We can see the warp wheeling around the galaxy, and because the galaxy is so vast, that wheeling is unimaginably slow by the measure of a human life, taking many hundreds of millions of years to come full circle. So what bent our galaxy in the first place? This is where the certainty fades and the wondering begins. There are a few leading ideas, and none has been settled. One possibility is that a smaller galaxy, one of the little companion galaxies that drift around the Milky Way, passed close by or even plowed partway through the outer disk at some time in the past, its gravity tugging the edges out of true and leaving this lasting warp behind. Another possibility reaches deeper still, into the vast invisible halo of dark matter that wraps around the whole galaxy. If that great unseen halo is itself slightly tilted, not perfectly lined up with the disk of stars, then its quiet gravity could be pulling the disk gently askew, holding the warp in place and setting it slowly turning. Both ideas are real and both are carefully weighed. We simply do not yet know for certain which one, if either, is the true cause. There is something quietly moving in the thought of it. The galaxy is not the perfect, serene, geometric thing we so love to draw. It is bent. It carries a gentle warp across its whole great body, perhaps the lingering fingerprint of some ancient encounter, a memory pressed into its very shape, still slowly turning long after whatever caused it has drifted away into the past. And it is turning right now, that vast, slow warp, far out at the edges of the disk where the stars thin into darkness. The great curved brim of our galaxy, lifting softly on one side, settling on the other, wheeling its long, unhurried way around the center across the ages, while you rest somewhere in the calmer, flatter middle of it all, carried gently along. Your galaxy is ringing, very faintly, like a bell that was struck long ago. Not ringing with sound, of course. Sound cannot cross the vast emptiness between the stars. It is ringing in its motion. When astronomers gathered together the positions and the movements of many millions of stars across the disk of the galaxy and studied them all at once, they found something no one had expected. The stars were not simply gliding around the center in calm, flat, orderly circles. They were also drifting very slightly up and down, rising a little above the plane of the disk and sinking a little below it as they traveled. And the pattern of that gentle rising and sinking, when astronomers drew it out, traced a beautiful, delicate spiral. A shape that curls in upon itself like the inside of a seashell, or the slow swirl of cream stirred just once into a cup of coffee. That spiral is the unmistakable signature of a galaxy still quietly vibrating. Picture the surface of a still pond, and a stone that was dropped into it some time ago. The ripples are still spreading outward, still rising and falling, carrying the memory of that splash across the water long after the stone has sunk from view. The disk of our galaxy is doing something very much like that, except the ripples are made of stars, each one gently bobbing up and down as it circles, all of them caught together in one slow, that shared shiver that has not yet faded away. The whole vast disk is faintly humming with it. It is a small motion, this rising and falling, gentle and unhurried, nothing a single star would ever feel as anything but its ordinary path. But spread across millions upon millions of stars and seen all together, it reveals a galaxy that is still trembling, ever so softly, from some disturbance in its past. And it took an extraordinary effort to notice it at all. Only by measuring the precise positions and motions of an enormous number of stars, more than had ever been charted before, could astronomers finally see the hidden spiral folded into the data, the quiet fingerprint of a galaxy still ringing. So something must have struck it. Something must have come along and disturbed the deep calm of the disk, set all those countless stars to swaying, and then moved on, leaving the galaxy to ring in its wake. The leading suspect is a smaller galaxy. The Milky Way is circled by a family of little companion galaxies, and at least one of them is thought to have plunged through or swept closely past our disk at some point in the past. Its gravity would have tugged on the stars as it passed, pulling them out of their flat orbits and stirring them into this lingering vertical sway. By how tightly the spiral is still wound, astronomers have tried to estimate when this happened. The clues suggest it may have been within the last few 100 million years, which is recent by the slow and patient clock of the galaxy, though the precise timing and the precise culprit are still being carefully worked out. The shape itself works almost like a clock. When the disturbance first struck, the spiral would have been loose and wide and open. As the years pass, it slowly winds tighter and tighter, each coil drawing in toward the next. So by measuring just how tightly the spiral is wound today, Astronomers can read backward, a little like counting the rings of a tree, toward the moment it all began. The galaxy, in its own slow and silent way, keeps time. And it stirs a quiet sense of connection, too. A few 100 million years ago, when that smaller galaxy may have brushed against our own and set the disk to ringing, the Earth was already here, turning under its young sun, its land just beginning to green with the earliest forests. The same slow ripple that began in those distant ages is still passing through the stars around us tonight. It is a strange and wonderful thing to sit with. The galaxy remembers. Long after the encounter, long after whatever passed through has wandered off into the dark, the disk still carries the event within it, written into the gentle up and down motion of its stars, like a great bell that goes on humming faintly in an empty hall long after it was rung. The galaxy holds quietly onto what once happened to it. And so, even now, all around you and beneath you, the stars of the disk are slowly rising and falling in their soft, almost imperceptible sway, tracing out that delicate, curling spiral, ringing on quietly in the dark. A whole galaxy still trembling, ever so faintly, from a touch it felt long ago, carrying you gently up and down along with it as you drift down toward sleep. Some stars are leaving the galaxy and they are never coming back. Almost every star you have ever seen is bound to the Milky Way, held forever in its gravity, circling the distant center on a long looping path it will follow for billions of years, the way our own sun does, the way nearly all stars do. They are residents of the galaxy. They belong to it. But every so often, astronomers come across a star doing something extraordinary. A star moving so unbelievably fast that the galaxy can no longer hold on to it. A star on a one-way journey, racing outward toward the edge of the Milky Way and beyond, destined to break free of it entirely and sail off alone into the vast dark emptiness between the galaxies, never to return. These are called the hypervelocity stars, and their speeds are difficult to imagine. An ordinary star like the Sun travels around the galaxy at a brisk but stately pace, fast by any earthly measure, yet held comfortably within the galaxy's grip. These rare runaways move many times faster still, fast enough to outrun the combined gravity of 100 billion suns and keep on going. Picture a single star tearing through the outskirts of the galaxy at well over 1 million miles in an hour, leaving its entire home galaxy behind it, bound for the emptiness beyond. How does a star ever reach such an impossible speed? For some of them, we have a good answer, and it is a violent one. It begins at the supermassive black hole at the center of the galaxy. Imagine a pair of stars, two suns orbiting closely around each other, bound together as a couple, drifting through the galaxy together as so many stars do. Now imagine that pair wandering too near the black hole at the center. The black hole's ferocious gravity can tear the couple apart, seizing one of the two and holding it captive, while flinging the other away with tremendous force, the way a stone whirled round and round on a string goes flying when you suddenly let it go. One star is trapped forever. The other is hurled outward at a furious speed, launched clear across the galaxy and out into the dark. A gravitational slingshot powered by the darkest object the galaxy holds. That explains some of these fleeing stars, but it does not explain all of them. Astronomers have found hypervelocity stars whose paths, when carefully traced backward, do not seem to lead from the center of the galaxy at all. Stars that appear to have been launched from somewhere else entirely, by some other force we do not yet fully understand. Perhaps the explosion of a companion star kicked them loose, blasting them away as it died. Perhaps they were flung out of a crowded cluster of stars in some chance gravitational tangle. Perhaps a few of them were even cast out of a neighboring galaxy and are only passing through our own. For a good number of these cosmic runaways, the honest truth is that we are still not certain what gave them their tremendous speed or where their long journey truly began. They are rare, and they are not easy to find. To catch one, astronomers must measure both how fast a star is moving and in which direction, and then notice the few whose speed is so great and whose path so clearly outward that the galaxy will never reel them back in. Out of the countless stars we have charted, only a small number have turned out to be these true escapees. And even moving as fast as they do, the galaxy is so enormous that their outward journey to its edge takes vast stretches of time, far longer than the whole history of life on Earth. If such a star could look back as it fled, it would watch the galaxy slowly shrink behind it. The great bright sprawl of stars drawing together over millions of years into a single small pinwheel of light, growing fainter and fainter against the black, until at last its whole home was just one more distant smudge among the galaxies. And then in time, even that would fade. There is something lonely and grand about them. A star born in the warmth and the crowd of the galaxy, among its billions of glowing siblings, now cast out, falling forever through an emptiness so vast that it may never come close to another star again, carrying its small light out into the truly dark places between the galaxies where almost nothing ever goes. And they are out there now, a scattered handful of them, streaking silently toward the edge of the Milky Way and past it, each one a tiny point of light on an endless outward journey, leaving home quietly behind, drifting alone into the deep and patient dark. Somewhere in your galaxy, perhaps 100 million black holes are hiding in the dark. They are the remnants of stars. When a truly massive star reaches the end of its life and finally runs out of the fuel that kept it shining, it can collapse inward upon itself so completely, so utterly, that nothing is left behind but a single point of gravity so intense that not even light can escape it. A black hole. The galaxy has been forming stars and losing them for billions upon billions of years, and across all that immense span of time, the deaths of its most massive stars should have left behind an enormous number of these dark remnants. When astronomers work through the arithmetic of it, the number they arrive at is staggering. There should be something like 100 million black holes scattered throughout the Milky Way. 100 million of them, drifting somewhere among the stars. And yet we have directly found only a tiny, tiny handful. A few dozen, perhaps, against that 100 million. The overwhelming rest are simply missing from our view. Sudmore. The galaxy should be quietly strewn with them, and we can scarcely locate any at all. The reason is the very thing that makes a black hole what it is. It gives off no light. A star shines, pouring out brightness across the dark, and so we can see it from enormous distances. A black hole, drifting alone in space, emits nothing whatsoever. It is a patch of pure darkness set against the darkness of space itself, invisible to every telescope we have ever built. Nearly all the ways we have managed to find black holes until now rely on them not being alone, on them having a companion star close beside them, whose gas they slowly pull inward and heat until it glows fiercely, betraying the hidden presence by its effect on what surrounds it. But a lone black hole, wandering solitary through the galaxy with no star to feed upon, offers us nothing to see. It is perfectly, completely dark, and it sails on through the galaxy entirely unseen. It helps, perhaps, to picture how small and how strange these hidden things truly are. A black hole left behind by a dying star might be only a few miles across, smaller than a city, and yet it can hold more mass than our entire sun, squeezed down into that one tiny dark point. 100 million such objects, each a thimble of crushing darkness heavier than a star, drifting silently through the galaxy, and almost none of them marked on any map we have. There are clever ways to catch a fleeting glimpse of them. Even so, a black hole's gravity bends the light of anything that lies behind it. And so, on rare occasions, when a wandering black hole happens to drift almost exactly in front of a distant star, it can briefly brighten and warp that star's light like an invisible lens sliding slowly across the sky. Astronomers have caught a few hints in exactly this way, watching a far-off star flicker and bend for no visible reason. And by carefully tracking how certain stars move, gently tugged about by something massive and unseen beside them, we have uncovered a small number more. But these are needles found in a haystack the size of a galaxy. The great multitude of those 100 million black holes remain hidden away, their locations unknown, their very number only an estimate. Each one we do manage to find feels like a small triumph, a single dark needle drawn carefully out of that immense haystack, and each one is a quiet reminder of just how many more must be out there, unseen and uncounted, for every single one we catch. And there is no need to fear them as you drift off to sleep. The galaxy is so unimaginably vast, and the distances between its stars so great, that these wandering darknesses pass nearly their whole existence far from us and far from one another, looping slowly through the emptiness. They are not lurking close. They are simply part of the quiet, unseen furniture of the galaxy, drifting through regions so remote and so empty that one could fall through the dark for ages and meet nothing at all. It is an eerie and humbling thought to rest with, all the same. As you lie here gazing up at the bright invisible stars, the galaxy all around them may be filled with a vast population of invisible objects, dark and silent and utterly unseen, drifting quietly among the points of light. Countless small darknesses woven all through the brightness, and we have found almost none of them. And they are out there tonight, those uncounted hidden black holes, drifting slowly through the galaxy on their own long, quiet orbits, dark against the dark, asking nothing, revealing nothing, simply present among the stars, as you rest gently beneath them all. You are living inside a bubble blown out by dying stars. It does not feel that way, of course. The space around the sun seems simply empty, the stars scattered evenly across the dark in every direction. But the truth is gentler and stranger than that. The sun and the earth and you upon it all sit near the middle of a vast and curiously empty cavity carved out of the gas of the galaxy. A great bubble of thin, hot, nearly empty space, roughly 1,000 light years across, with the sun drifting somewhere near its very heart. Astronomers call it the local bubble, and we are living inside it. How does a bubble like this come to be? It is blown, slowly, over millions of years, by the deaths of stars. When a massive star reaches the end of its life, it does not simply flicker out and fade. It explodes in a supernova, one of the most violent events in all the universe, for a brief time outshining entire galaxies and blasting a tremendous wave of energy and matter outward into space. That expanding shockwave sweeps up the thin gas around it as it goes, pushing it outward in every direction, clearing a great hollow in the gas between the stars, much like a bubble blown into thick liquid. Long ago, a whole series of such explosions went off in this region of the galaxy, one after another across millions of years, and together they swept the surrounding gas away and hollowed out the enormous cavity we now find ourselves resting inside. We are, in the most literal sense, living within the cleared-out space left behind by the deaths of ancient stars. The explosions that carved it were not so very long ago, as the galaxy counts time. The clearing is thought to have begun perhaps some 10 or 15 million years in the past, the work of a number of dying stars across that span, their shock waves overlapping and merging into one great expanding hollow. By the patient measure of the cosmos, our quiet bubble is a fairly recent thing, and it is still gently growing even now, its soft walls drifting slowly outward into the surrounding dark. And there is something quietly beautiful waiting at the edges of our bubble. As all that swept-up gas was pushed steadily outward and began to pile up along the boundary of the cavity, it gathered there into a dense shell, a great curved wall of compressed gas surrounding the hollow. And within that compressed shell, gravity has been able to draw the gas together into new stars. Astronomers have discovered that nearly all the young stars now forming in our part of the galaxy lie strung along the surface of this very bubble, dotted around its walls like tiny beads of dew gathered on the rim of a soap bubble. The same explosions that cleared our quiet, empty pocket also sowed around its edges the seeds of brand new suns, the endings of old stars, gently preparing the way for the births of new ones. It took us a surprisingly long time to realize where we were, living inside the bubble, surrounded on every side by its thin emptiness. We could not easily see its shape. Only by patiently mapping the gas and the young stars around us in 3 dimensions have astronomers been able to trace the great rounded walls of the cavity and recognize at last that the sun sits near the center of an immense hollow, blown clear long before any human ever looked up to wonder at the sky. And we are only passing through. The sun does not truly belong to this bubble, and the bubble does not belong to the sun. On its long, slow orbit around the galaxy, our star simply happens to be drifting through this cleared hollow now, in this particular stretch of cosmic time, the way a traveler crosses a wide and quiet clearing in a forest. In ages still to come, it will move on, out of the bubble and into the gas beyond, and other stars will wander through the hollow in their turn. It is a humbling place to find ourselves. We did not arrive in this empty pocket by any plan, and the emptiness around us is far from meaningless. It is the lingering aftermath of stars that lived and died before us, their final, violent gift, the very space we now drift quietly through. We are sheltered, in a way, inside the slowly fading echo of their endings. So tonight, as you rest, you might picture the soft, invisible walls of that great bubble far around you in every direction, 1,000 light years away on all sides, glowing faintly here and there with the light of newborn stars. And in the middle of it all, in the deep, quiet hollow swept clear by stars long gone, the sun and the earth and you upon it, drifting gently and safely through the cleared and peaceful dark. Quite near the sun, a colossal wave is rolling slowly through the galaxy. It is not a wave of water, but a wave made of gas, of the very clouds from which new stars are born. For a long time, the nearby clouds of star-forming gas seemed simply scattered around us, just patches of cosmic material strewn across our corner of the galaxy with no particular order to them. Then, in the year 2020, astronomers built a careful three-dimensional map of those clouds, charting exactly where each one sits in the space around us. And when they finally stepped back and looked at the completed map, a hidden shape leapt out at them, one that no one had ever seen before. The clouds were not scattered at random at all. They were strung together, one after another, into a single, enormous, graceful wave. It is staggering in its size. This vast structure of gas stretches some 9,000 light-years across our region of the galaxy, an immense ribbon of the raw material of stars. And it is not a straight line. It rises and it falls, like a great ocean wave caught and held in a single frozen instant, lifting up above the flat plane of the galaxy and then dipping down below it, crest and then trough, undulating gently across thousands of light-years of space. Astronomers gave it a name. They call it the Radcliffe Wave. It is the largest structure of its kind we know of anywhere near home, a long and gentle cosmic ripple made of the very stuff that stars are formed from, lying almost in our own cosmic backyard, and yet entirely unnoticed by anyone until we finally mapped our surroundings in 3 dimensions. Threaded along this great wave are many of the familiar nurseries of new stars that lie nearest to us. The glowing clouds where fresh suns are quietly being kindled. They are not a random sprinkling after all. They are like pearls strung along a single vast and hidden thread. A thread that runs for thousands of light-years through the gas around us, gathered together into one sweeping shape we had simply never been able to see. But the discovery did not end with the wave's shape. More recently, astronomers studying the motion of all that gas found something even more wonderful. The wave is not frozen in place at all. It is actually moving, oscillating, much the way a wave travels along a rope when you take one end and give it a single flick. The crests of it are slowly sinking and the troughs are slowly rising, the whole immense ribbon of gas undulating up and down through the plane of the galaxy in a slow, majestic, rolling motion. A real wave traveling through the body of the galaxy, except a wave 9,000 light-years in length, made not of water, but of the glowing clouds where stars are born. And the great question is simply, why? What set this enormous wave into motion? What gave the star-forming gas near us this rolling, undulating shape and started it traveling? Astronomers are not yet sure. Some have wondered whether a small galaxy, or perhaps a dense clump of dark matter, passed through our region long ago and disturbed the gas, the way a stone dropped into a pond sends ripples spreading across the water. Others suspect it may arise from the natural way that gas gathers and flows through the disk of a galaxy. The honest answer for now is that we have found this beautiful wave and watched it slowly move, and yet we do not fully understand what set it rippling. And it is not only a shape but a promise. All along that great rolling ribbon, within its dense and glowing clouds, new stars are slowly taking form, gathering quietly out of the gas, drawing themselves together toward the moment they will ignite. The wave is a nursery as much as a structure, a vast cradle of suns not yet born, drifting through the galaxy beside us, Some of the stars that will one day shine down on distant future skies may be gently assembling within it even now. There is something almost tender hidden in it. The sun itself, on its own long journey around the galaxy, is thought to have drifted across this very wave in the distant past, passing through the gas long ago, and it may cross paths with the wave again far in the future. We live beside a slow and rolling swell of the galaxy's own star stuff, a wave so impossibly vast and so impossibly gentle that for the whole of human history we never once knew it was quietly breaking all around us. And it is rolling out there still, that enormous and silent wave, lifting and falling across 9,000 light-years of the galaxy, a slow swell of glowing gas and forming stars, rising and sinking through the dark, unhurried and immense and serene while you rest gently here beside it tonight. A vast cloud is falling toward your galaxy, and one day it will strike it. Far above the disk of the Milky Way, out in the dark beyond the familiar stars, there drifts an enormous cloud of gas. It is made mostly of hydrogen, the simplest and oldest substance in the universe, the very same gas that stars are born from. And it is not sitting still. It is plunging downward toward the disk of the galaxy, falling inward through space on a long curving path that will, in time, bring it crashing into the great plate of stars we live within. The cloud is staggeringly large. It stretches some 11,000 light-years from end to end, far larger than you might ever picture a single cloud to be. A tremendous streak of gas, longer than the distance spanning countless stars. If your eyes could somehow see it glowing up in the night sky, it would stretch across a span many times wider than the full moon, a great luminous smear hanging above the horizon. It has a name. Astronomers call it the Smith Cloud, after the young astronomer who first noticed it long ago. You could never see this cloud with your eyes, even if it hung directly overhead. It is dark, made of cold, thin gas that gives off no visible light at all. We know it is there only because that hydrogen quietly shines in radio waves, a kind of light far below the reddest red your eyes can sense, and our great radio telescopes can listen for it. Mapped in that invisible glow, the cloud reveals its true shape, a long curving streak of gas plunging steadily down toward the galaxy. And it is racing. The cloud is falling toward the galaxy at a tremendous speed, well over 100,000 miles in every hour, drawn down by the galaxy's gravity. By the best reckoning, it will strike the disk of the Milky Way in perhaps 30 million years or so. When it does, it will not be a quiet arrival. The cloud will slam into the gas of the disk and compress it violently, and out of that great collision, astronomers expect a brilliant burst of new stars will be born. A long cascade of fresh suns kindled by the impact, a kind of slow firework set off across the sky, long after we are gone. 30 million years sounds like an eternity, and by the measure of a single life it surely is. But the galaxy keeps a far slower clock. 30 million years is only a small step in its long history, the quiet blink between one age and the next. By that measure, the cloud's great fall is nearly complete. It is already most of the way home. But where did this great falling cloud come from? That is the genuine puzzle. There are a few ideas, and they disagree. One possibility is that the gas was once part of the galaxy itself, flung high above the disk long ago by the violence of exploding stars, lifted up like spray thrown from a breaking wave, and is only now falling back down, returning home after a long arc through the dark. Another possibility is that the cloud is a visitor from outside, a clump of ancient gas that never belonged to our galaxy at all, drawn in slowly from the emptiness beyond, perhaps even wrapped in a hidden cocoon of dark matter that has helped it hold together on its long fall inward. We do not yet know which story is the true one. The cloud keeps the secret of its origin as it falls. There is something quietly stirring in the thought of it. A collision is coming, gentle by the slow measure of the cosmos, set to unfold across millions of years, that will one day kindle a whole new generation of stars in our galaxy. An ending and a beginning, folded into the same long fall. And it is already on its way, already drawn in, the outcome already set in motion, though it will not arrive for ages yet. And there is a longer thread to follow, if you like. The hydrogen in that cloud is ancient, perhaps almost as old as the universe itself. When it finally strikes the disk and gathers into new stars, some of those stars may in time form planets of their own, and on some far world, who can say, that same gas might become oceans, or air, or even the soft stuff of living things. The cloud carries the raw beginnings of all of that, falling quietly toward us through the dark. So it falls on, that great silent cloud, high above the disk of the galaxy, sweeping down through the dark on its long, slow arc, carrying within it the seeds of stars that will not shine for tens of millions of years. Falling patiently toward a home it will not reach for a very long time, while you rest quietly below, beneath a sky that does not yet know it is coming. No one knows how much your galaxy weighs. It seems like the kind of thing we surely ought to know by now, one of the very first facts you would expect in any description of the Milky Way. How massive is it? How much total stuff does it hold? And yet, when astronomers try to answer that simple question, their estimates spread out across a wide and uncomfortable range. The true mass of the galaxy might be one number, or it might be twice that, or somewhere in between. We genuinely do not know the weight of our own home to better than a rough guess. Part of the difficulty is that most of the galaxy's mass is invisible. The stars and the glowing gas, all the parts that shine, make up only a small fraction of the whole. The rest is the unseen dark matter, the mysterious stuff that gives off no light and can be felt only by its gravity, wrapped in a vast halo around everything. To weigh the galaxy, we cannot simply add up the stars. We have to measure how its gravity tugs on things, on the motions of distant stars and small companion galaxies looping around it, far out in the dark. Think of trying to weigh something you cannot fully see by watching how it moves the things around it. To weigh the galaxy, astronomers watch the little companion galaxies that loop around the Milky Way far out in the dark, and the most distant stars trailing through the outer halo. The faster these far-flung travelers are swung around, the more hidden mass must be pulling on them. But they are few and dim and terribly far away, and so the weighing stays rough, an estimate drawn from only a handful of distant clues. And the answer matters more than it might first seem. How much a galaxy weighs shapes its whole story. How it formed, how it has drawn in and swallowed smaller galaxies over the ages, how it drifts among its neighbors, and what will become of it far in the future. To not know the weight of our home is to be uncertain in a quiet way about both its past and its fate. The number sits hidden beneath everything, and we cannot quite pin it down. Imagine not knowing your own weight to within a factor of 2, whether you were one size or fully twice that. For a person, it would be absurd. For a galaxy spread so thin across such unimaginable distances, most of it dark and silent and far beyond our reach, it is simply the honest state of things. We are still learning how to weigh the place we live. Even the sun's own position within the galaxy is something we measure rather than simply know. Our distance from the center, pinned down only in fairly recent times, and still carrying a small uncertainty of its own. In every direction, inward and outward alike, we are still quietly taking the measure of our home. And there is a deeper strangeness still. The galaxy has no clear edge. We like to draw it with a crisp, bright rim, a definite boundary where the Milky Way stops and empty space begins. But that is not how it truly is. The stars simply grow sparser and sparser as you move outward, thinning gradually into the dark, with no line you could ever point to and say, "Here, this is where the galaxy ends." And the great invisible halo of dark matter reaches out even farther, fading away so gently into the space between galaxies that no one can mark its real border. We sometimes say the bright disk of the galaxy is about 100,000 light-years across, and that is a fair measure of the part that shines. But the great dark halo of unseen matter reaches out far beyond that, perhaps many times farther, with no firm boundary anywhere. Out there, the last faint stars of the galaxy thin away to nothing, and the dark matter fades so gradually that asking where the galaxy ends is a little like asking where a fog ends. There is no line. There's only less and less and less. There is a quiet humility in that. The most basic measurements of our home, its weight, its size, where it stops, remain blurred and uncertain, written in soft pencil rather than ink. We live inside something so vast that we cannot fully weigh it or find its edges, something that fades away into the dark in every direction without ever truly ending. So picture the galaxy not as a sharp, bright disk hanging in empty space, but as something softer than that, its stars thinning gently outward, its unseen weight reaching far beyond the light, dissolving slowly into the dark on every side with no true edge anywhere. A vast and boundless thing, holding you somewhere within it, far from any edge at all, while you rest in its quiet middle tonight. Your entire galaxy is threaded with invisible magnetism. We do not usually think of a galaxy as magnetic. We picture stars and gas and dust, the bright and the dark, but not magnetism, which seems like something small, the pull of a magnet on a refrigerator door or the gentle swing of a compass needle. And yet, woven all through the Milky Way, running along its great spiral arms and filling the space between the stars, there is a vast and ghostly magnetic field. It stretches across the whole galaxy, tens of thousands of light-years wide, an invisible web of magnetism threaded through everything. This galactic magnetism is extraordinarily gentle. If you could hold a compass out in the space between the stars, its needle would feel a pull thousands of times weaker than the one it feels here on Earth, so faint it would barely stir at all. But what the field lacks in strength, it makes up for in sheer size. It spans the entire galaxy, and though it is feeble at any single point, across such immense distances, it becomes a real and shaping force, gently herding the gas of the galaxy, helping to guide where new stars are born, and steering the paths of the tiny, fast-moving particles called cosmic rays that stream endlessly through space. We cannot see this magnetism directly, of course, but it leaves quiet fingerprints. Out in the galaxy, tiny grains of dust drifting between the stars are slowly turned by the field. all lining up the same way, like a field of tall grass combed flat by one steady wind. And as starlight passes through those aligned grains, it is subtly altered, tilted in a way our instruments can read. By gathering that faint tilt in the light of countless stars, astronomers have slowly traced the hidden field, mapping the invisible magnetism arm by arm across the galaxy. Consider those cosmic rays for a moment. They are tiny particles, mostly the bare cores of atoms flung out by exploding stars and other violent events, and sent racing through the galaxy at very nearly the speed of light. Left to themselves, they would simply fly straight out of the galaxy and be lost to the void. But the invisible magnetic field catches them, bending their paths into great looping spirals, holding them within the galaxy and letting them wander for millions of years. Some of those very particles drift gently down onto the Earth even now, their long journeys shaped at every step by the magnetism threaded through the galaxy. And the field is not a tangled mess. Across much of the galaxy, it follows a grand and orderly pattern, running along the sweep of the spiral arms, as though the whole galaxy had been combed in great curving lines. Picture iron filings on a sheet of paper arranging themselves around a magnet, tracing out the hidden lines of force. The galaxy does something like that on an unimaginable scale. Its gas and dust quietly aligned along invisible magnetic lines that wind around the center for tens of thousands of light years. It is humbling to think that a force so faint, one a compass could barely feel, can quietly shape the motion of particles and the birth of stars across an entire galaxy, simply by being everywhere at once, patient and unbroken, through all the long ages. And here's the question we cannot fully answer. Where did it come from? A magnetic field this vast and this orderly does not simply appear. The leading idea is that the galaxy works like a slow and enormous dynamo. As the galaxy turns, its swirling, churning gas, charged and in motion, can gradually amplify a magnetic field over billions of years, winding it up and strengthening it, the way a generator builds a current out of spinning motion. But a dynamo needs a seed to begin with, some faint whisper of a magnetic field already present for it to take hold of and amplify. And where that first seed came from, that original faint magnetism at the very dawn of the galaxy, reaches back into the deep mysteries of the early universe, to a time we can barely glimpse. We do not truly know how the magnetism of the galaxy was first born. It is a strange thing to hold in mind. All around the stars, unseen and silent, runs this vast invisible field, shaping the galaxy in quiet ways, present everywhere and visible nowhere, its very origin lost in the first ages of the cosmos. We have lived our whole history inside it and never felt it at all. And it is there right now, that gentle ghostly web threading through the whole galaxy, running along the great spiral arms, drifting unseen between every star, including the small warm star that lights your sky. An invisible magnetism, faint as a held breath, wraps softly around everything, while you rest beneath it in the dark. There is a part of the sky we have never been able to see through. When you look up at the band of the Milky Way on a dark night, that soft glowing river of stars, you are gazing into the crowded heart of our own galaxy, looking edge-on through its thick disk. And that disk is dense, packed with stars and heavy with clouds of dust and gas, so dense in fact that we cannot see through it. Whatever lies behind that bright band, out beyond our galaxy in those directions, is hidden from us, blocked by the glare and the dust of the Milky Way itself. Astronomers have a name for this hidden strip of sky. They call it the zone of avoidance. It is no small patch. The band of our galaxy covers a wide swath of the entire sky, and behind all of it, the universe beyond lies veiled. There are whole galaxies out there, perhaps a great many of them, that we have never once seen, simply because they happen to sit behind the curtain of our own galaxy's light. For a long time, that part of the universe was almost entirely a blank space on our maps, a great unknown region. Not because nothing was there, but because our own home stood squarely in the way. And hidden somewhere in that blocked region is one of the strangest puzzles in all of astronomy. For decades, astronomers have known that our galaxy, along with thousands of other galaxies nearby, is being pulled through space, all of us drifting together toward one particular direction, drawn by the gravity of something enormous. And part of whatever is doing the pulling lies right in the zone of avoidance, behind the band of the Milky Way, in the region we cannot easily see. Astronomers named the source of the pull the Great Attractor, an immense concentration of mass tugging quietly on our whole corner of the universe. In recent years, we have found ways to peer a little way behind the curtain. Certain kinds of light slip through the dust where ordinary starlight cannot. Radio waves and the deep glow of infrared and X-rays from the hottest gas. Using them, astronomers have begun to map what hides in the zone of avoidance. They have found great crowds of galaxies back there, whole clusters that had been completely concealed, part of the immense gathering of mass that draws us on. And our entire galaxy, with all its stars and you among them, is drifting toward it at a speed of hundreds of miles every second, carried steadily through the dark toward something we still cannot fully see. Astronomers estimate that something like 1/10 or more of the whole sky is veiled in this way, and with it, untold numbers of galaxies we have never counted. Whole islands of stars, each one holding its own hundreds of billions of suns, sitting quietly behind the curtain, present but unseen, waiting for us to find a way to look. And the pull does not stop with the Great Attractor. Beyond it, even farther away and even harder to see, lies a still greater gathering of galaxies, a vast and distant supercluster whose faraway gravity may be tugging on us as well, drawing our whole local crowd of galaxies across the universe toward regions we are only beginning to chart. We are riding a slow current we cannot fully trace, flowing through the cosmos toward a destination hidden, in part, behind our own galaxy's glow. There's a quiet irony in it that astronomers have long lived with. We have built telescopes that can see almost to the very edge of the observable universe, gathering the ancient light of galaxies billions of light years away. And yet a whole slice of the nearby cosmos, just behind the band of our own home, stays stubbornly out of reach. The faraway lies open to us. It is the near that hides. If only we could step to one side, just for a moment, and peer around the edge of our own galaxy, a hidden portion of the universe would quietly open up before us. There is something humbling and a little wondrous in that. Of all the things that block our view of the universe, one of the very greatest is our own home. We sit inside the very thing that obscures our sight, peering out through a glowing band that hides a whole piece of the cosmos from us, including some great unseen weight quietly drawing us toward it across the dark. So somewhere behind that soft band of light arching across your sky tonight, beyond the near stars of the Milky Way, there are galaxies you will never see, and a vast hidden mass gently pulling your whole galaxy toward it through the emptiness. Out of sight, beyond the curtain, while you rest quietly beneath the glowing veil of home. Some of the stars in your galaxy are almost as old as time itself. Scattered through the Milky Way, and especially out in the great halo that surrounds the bright disk, there are stars of extraordinary age, ancient suns that form near the very beginning, when both the galaxy and the universe were young. These are not like our own middle-aged sun. They are old, far older, some of them among the first generations of stars ever to shine, and a few of them are so old that their estimated ages come startlingly close to the age of the universe itself, which is something like 13.5 billion years. In fact, there was a famous case, a particular ancient star not far from us, whose age, when astronomers first carefully measured it, came out so large that it appeared to be older than the universe. Which is, of course, impossible. A star cannot be older than the cosmos that made it. It was a genuine puzzle for a time, a single star that seemed to predate everything. The resolution, when it came, was not some grand mystery, but the quiet honesty of measurement. Working out the true age of a star is fiercely difficult, full of small uncertainties, and when those were carefully refined, the star's age settled down to something just under the age of the universe after all. Ancient almost beyond imagining, but not impossible. Still, it came so very close. How can we tell that a star is ancient in the first place? One of the clearest signs is what it is made of. The very first stars formed from almost nothing but hydrogen and helium, the simple gases that filled the young universe, because the heavier elements, the carbon and the iron and the gold, had not yet been forged in the hearts of stars and scattered out into space. So a star that is nearly pure hydrogen and helium, almost untouched by those heavier elements, must have formed very early, before later generations of stars enriched the galaxy. These ancient suns wear their age in their very substance, plain and unmistakable. Many of them gather in great spherical swarms called globular clusters, tight balls of hundreds of thousands of ancient stars, orbiting far out around the galaxy in its halo. Each one is a little time capsule, a knot of some of the oldest stars the galaxy ever made, drifting together through the dark since nearly the very beginning, holding their light steady across almost the whole age of the cosmos. Part of why they have lasted so long is that the smallest of these ancient stars burn with great patience. A small, cool star sips its fuel so slowly that it can shine steadily for many billions of years, far longer than a bright, hot star like our sun will ever manage. So the dimmest of the old stars are also the most enduring, quietly outlasting countless brighter suns that flared up and faded while they burned softly on. They are something like the marathon runners of the galaxy, pacing themselves gently across almost the whole of cosmic time. And there is a strange intimacy in looking at one. The light reaching your eye from such a star set out on its journey long ago, and the star that sent it has been shining since before the earth was a world, since before the sun itself first began to shine. To glimpse one, even as a faint speck, is to look almost all the way back to the beginning with your own quiet eyes. And that brushing up against the limit points to something we still genuinely struggle with. Dating the very oldest stars and pinning down exactly when our galaxy first began to form its stars remains one of the hard, unsettled problems of astronomy. We can say that some of these stars are nearly as old as the universe. We cannot yet say precisely how old or precisely when the Milky Way lit its earliest suns. The beginning of our galaxy is written in these ancient stars, but in a hand we cannot quite read. There is something deeply moving in their presence. These ancient stars have been shining since before the Earth existed, before the sun, before almost anything we know. They were here at the dawn, and they are here still, quietly burning, having watched the whole long history of the galaxy unfold around them. They are the galaxy's elders, its living memory of the beginning, and they are out there tonight, those ancient stars scattered through the dark halo around the galaxy, burning low and steady as they have for nearly the whole age of the universe. Old beyond all reckoning, patient beyond all measure, still shining softly in the dark, just as they were at the very beginning as you drift toward sleep beneath them. There is another great galaxy drifting slowly toward your own. Far across the emptiness of space, a little over 2 million light-years away, lies Andromeda, the nearest large galaxy to our own. It is a vast spiral much like the Milky Way, a great wheel of hundreds of billions of stars, and on a clear dark night, you can just glimpse it with your unaided eye, a faint smudge of light, the most distant thing most people will ever see without a telescope. And Andromeda is moving. Across the millions of light years between us, it is drifting our way, drawn by the long, slow pull of gravity between the two galaxies. For many years, astronomers were quite confident about what would happen next. They had measured Andromeda's approach, and the story seemed settled. In roughly 4 or 5 billion years, the two great galaxies would meet and crash together, merging in a slow and spectacular collision lasting hundreds of millions of years, until at last they fused into a single new galaxy. It was taught as near certain, a fixed point in the far future of our home, the Milky Way and Andromeda destined to become one. But more recently, astronomers took a closer and more careful look, and the certainty began to dissolve. The trouble is that a head-on collision depends on exactly how Andromeda is moving, not only toward us, but also a little to the side, and that sideways drift is extraordinarily hard to measure across such an enormous distance. And there is more. Our two galaxies do not travel alone. They are each surrounded by smaller companion galaxies whose gravity gently nudges them this way and that. When astronomers carefully folded in those nudges and the real uncertainties in Andromeda's motion, the clean old story came apart. By the latest reckoning, a collision is no longer certain at all. It now looks closer to a coin flip, roughly an even chance over the next many billions of years. The galaxies might still merge, or they might simply sail past one another, or circle for ages without ever truly colliding. Measuring how a galaxy 2 million light-years away is drifting sideways is one of the most delicate feats in all of astronomy. The motion is so slow and the distance so vast that it is a little like trying to watch the hour hand of a clock move on a tower miles away. Astronomers must compare images taken years apart, searching for the tiniest shift in position against the far more distant background of the universe. And a mere whisker of difference in that measurement can be the difference between a future collision and a quiet near miss, which is part of why the answer has proven so very hard to settle. There is something quietly remarkable in that. A future we thought we knew, written confidently into the story of our galaxy, has softened back into an open question. The fate of the Milky Way, billions of years from now, is not settled after all. It is uncertain, undecided, still hanging in the balance of forces too delicate for us to fully measure. And even if the two galaxies do one day meet, it would be the gentlest sort of collision you could ever imagine. The stars within a galaxy are so far apart, with such vast emptiness between them, that almost no stars would actually strike one another. The two galaxies would pass through each other more like two clouds quietly merging than like two solid things crashing, their stars gliding past in the dark, slowly rearranging into a new shape over an unimaginable stretch of time. If the two galaxies do one day merge, they would slowly lose their graceful spiral arms, swirling and settling over billions of years into a single vast rounded swarm of stars, a great elliptical galaxy where two pinwheels used to turn. From some far world adrift inside it, the night sky might blaze with the gathered light of 1 trillion suns, and yet even that grand transformation would unfold so slowly, across such an immensity of time, that no single night would ever look any different from the one before it. And all of this lies so impossibly far ahead that it is hard to truly grasp. 4 or 5 billion years is longer than the Earth has so far existed. By the time the two galaxies might meet, our own sun will have changed beyond all recognition, and the night sky over whatever remains will be utterly different from the one above you now. This is a tale of the deep, deep future. Gentle and slow and far away, nothing that touches the quiet of tonight. So tonight, that faint smudge of Andromeda hangs in the sky, drifting slowly toward us across the dark, its future and ours still gently undecided. Two great wheels of stars leaning toward each other across 2 million light-years of emptiness, in no hurry at all, while you rest softly beneath them, billions of years before anything at all is decided. In all your vast galaxy, we have never once heard from anyone else. The Milky Way is old, and it is enormous. It has been turning for well over 13 billion years, and it holds hundreds of billions of stars, far more stars than there are grains of sand on a long ocean beach. And we now know that planets are common, that most of those stars have worlds of their own circling them. Billions upon billions of planets scattered through the galaxy, many of them perhaps gentle enough for life. With so much time and so many worlds, it is natural to wonder whether life has arisen elsewhere, whether somewhere out there, around some distant star, others might be looking up at their own night sky, quietly wondering the very same thing. Consider for a moment just how many chances there have been. Hundreds of billions of stars, and circling them, very likely, a number of planets greater still, many of them rocky worlds resting at gentle distances from their suns, with warmth and perhaps water, and long ages in which something might slowly stir. The sheer numbers are staggering. With so many worlds and so much time, the quiet begins to seem almost surprising, almost too quiet, and that surprise is the very heart of the puzzle. And yet so far we have heard nothing. We have listened, turning our great radio dishes toward the stars, searching for any signal, any whisper, any sign that we are not the only ones. And in all of that listening, the galaxy has stayed silent. We have found no clear sign of anyone else at all, anywhere, in all those billions of stars. This is one of the strangest and most haunting puzzles we know, and it has no agreed answer. The galaxy is so old and so vast that you might think life should have had every chance to arise many times over, and perhaps even to spread from star to star across the long ages. So where is everyone? Why the silence? Every possible answer is for now only a guess. Perhaps life is far rarer than we hope, and we are among the very few or even alone. Perhaps life is common, but the kind that builds and listens is fleeting, flickering up and fading away before it can ever be heard. Perhaps others are out there right now, and we simply do not yet know how to listen, or have not listened long enough, or are separated from them by gulfs too vast for any signal to cross in time. We honestly do not know. The silence has not yet been explained, and it is worth remembering how young and how small our listening has truly been. We have been able to send and receive signals across space for only about a century, the very briefest flicker against the galaxy's billions of years. Our searches have swept across only a tiny fraction of the stars, listening for only certain kinds of signal for only a little while. The silence we have heard so far may be nothing more than the silence of someone who has barely begun to listen, standing in one small corner of an enormous and ancient hall, straining to hear. We have hardly opened our ears. Whatever the truth turned out to be, we have only just started to ask the question with any seriousness, and the asking itself may take a very long time. There is a strange and gentle weight to it, lying here beneath the stars. Either we are alone in this immense galaxy, a single small candle of life and thought burning in all that darkness, which is a lonely and astonishing thought. Or we are not alone, and the night above you is quietly full of others, also looking up, also wondering, separated from us only by the vast and patient dark. Either possibility is almost too large to hold in the mind at once, and perhaps there is something beautiful in not knowing, at least for now. The question itself is a kind of quiet companionship. Every time someone looks up and wonders whether anyone might be looking back, they join a long and gentle line of people, stretching across all of history, who have gazed at these same stars and asked the same thing. Tonight, lying here, you are part of that wondering, joined to everyone who ever looked up in the dark. And so the question rests, unanswered, as it has for as long as anyone has thought to ask it. Somewhere above you, scattered across the galaxy, are countless stars and countless worlds, silent for now, keeping their secret. Whether we are alone or in good company, the night does not yet say. It only turns slowly overhead, vast and quiet and full of stars, while you drift gently down towards sleep beneath it. And so we come to the end of our slow wander through the mysteries of the galaxy. 20 small windows onto how much we still do not know about the great turning wheel of stars we call home. There is a quiet comfort in that, I think, in how much wonder is still out there, waiting in our own backyard among the stars. If you are still awake, still drifting somewhere between wondering and sleep, there is another gentle journey waiting for you whenever you are ready. Another long, slow wander through the wonders of the night. Let it carry you onward into the dark, or let this be the place you finally let go and drift off. Either way, you are held right here inside this vast and gentle galaxy, turning slowly all around you. Rest now, my friend. Sweet dreams among the stars.